Hello everyone, it's Nikita from Schema, and today I walk you through a complete end-to-end workflow from early concept design using Schema and ShapeDiver, all the way to the BIM delivery in Revit with Rhino.Inside in the loop. Here is what we're gonna cover today. Firstly, we start from the pre-designed project in Schema, which was created using highly detailed units uploaded as Revit model groups. From there, based on the schematic floor plan layout, Schema generates a data-rich analytical model on the fly. At this stage, Schema defined where the exterior walls should go, where the interior, demising, parapets, slabs, roofs, etc. Essentially, everything needed for the high-fidelity export back to Revit. Next, we will access this analytical model in a Grasshopper using Schema Rhino plugin and generate a parametric facade definition on top of it, which respect directly to the building geometry and embedded data. Next, we will convert our script into a web-based application using ShapeDiver. From there, our script becomes available beyond Grasshopper, allowing the facade to be configured directly in a browser. Finally, we connect Schema with ShapeDiver for the seamless data exchange and export building from Schema to Revit using Schema Revit application, and from the ShapeDiver via Rhino and Rhino.Inside. As an outcome, we will have the fully coordinated BIM model, which was generated based on the single source of truth, which is Schema Analytical model. So let's see how it works in practice. We first need to go to Schema and copy the demo project into our tenant. To do that, you just need to go to the Demo tab and click to the high-rise residential building project. This will create a copy of that project in your own tenant, so you are free to explore, do any changes without affecting the original file. So if you hover over a floor and double-click, you will activate the planning mode. At this stage, we can do the floor plan layout. And the units that you can see here, they represent a highly detailed Revit model groups. Let me show you how it works. We have a Revit container file where my units formatted as model groups, and we have a Schema plugin, which allow me to upload my units to Schema. And at this stage, Schema capture all the relevant information about these units, like walls positions, nested model groups, furniture, doors, windows, etc., as well as creating their own metadata to make these units parametrical. And when you see these units in Schema, they essentially a proxy representation of the highly detailed model groups. So we are free to move them, rearrange, reallocate, without worrying about intersections or clash issues, which is pretty common problem while working with Revit model groups. Or we even can parameterize our units and to stretch them and morph into a new shape of my building. And as you can see, all these changes applied within identical layouts across all my floors. So let's undo all my changes. Yeah, here we go. Let's take the next steps in the workflow. Now we're going to explore Schema Analytical model and analyze all the key features of it. So we can go back to Schema and we can go to the BIM tab. And here we can preview the analytical model, which was generated based on the special logic of my floor plan layouts. And at this stage, as you can see, we identify the demising walls, exterior walls, etc. So in Schema, you just simply allocate your units without thinking about where your walls should go. You just do the special logic. And we generate all the BIM elements on the fly. So meaning that if we go back to my massing model, and if we do any changes within the special logic, like here, for instance, I just want to move all these units and create some sort of a courtyard here in this space. Let's save it. Yeah. You can see that I have a hole which will be treat it as a courtyard for my BIM model. So if I now go to the BIM model, I can see the updated shape. I can see the roof, I can see the hall, I can see automatically generated parapet walls around this courtyard, and I can see that I have exterior walls inside. So as you can see, all the BIM elements were generated, and this model is a critical part for experts in project back to Revit. How it works. If I go to Revit, I can create a new project. It can be empty file, it can be your firm specific template, depending on your workflow. So here on the Schema plugin, we just need to switch to the project connector, and we will have access to all projects in my tenant. So I can click to the project that I just copied, and here I can see the same analytical model. I also can go to a particular building and manage what type of elements I want to exclude or include in my expert. For this case, I don't need to have external walls as well as parapet. I only need to have my demising, interior, roof, slabs, and the unit position, because I will generate the facade in a Grasshopper based on this analytical model. So I can switch it on and go back, press export, and the export usually takes a few minutes. So while export is running, let's move on to the next chapter. We will now fetch the analytical model in a Grasshopper and create a parametrical facade on top of it. Let's firstly open Rhino, and we can start from the empty file in a Grasshopper. And the first thing to do here is to be sure that you have a Schema plugin installed. So it's available through the package manager. So if we go to the package manager, we can just type Schema, and we can see the latest available version of the plugin. Yeah, we can install it. And the plugin itself is really simple. It has only 3 components, and the first components we need to use is called Schema companies. After placing these components, it prompts you to provide your credentials. So I can just provide my login and password and connect. We have our companies, and what's happened right now is we authorized on the Schema side. So you also can do it by pressing right mouse button and pressing login button, and this will open the same pop-up menu. So now we have access to all tenants which I belong to. Basically, you will belong only to one tenant, but there is no limitation to attend to multiples. And the thing that we must have here is ID of our company, of our tenant. Now we can retrieve the JSON file of this analytical model, and we need to use these company IDs and need to plug it to the Revit export model component. And the last thing here is we need to provide a URL to a particular project. I can just go back to Schema. I can copy the URL and paste it into the text component in Grasshopper. I can plug it, and voila, I successfully have the Schema analytical model as a JSON file. And here we have the last component, which takes this JSON file and convert it into native Rhino objects. As you can see here, we have a preview of all the elements inside this analytical model, including units and their embedded data. For instance, if I just explore the walls, I can see that all my walls are represented as lines, where each branch represent the level. Yeah, I can easily see it if I explore my tree by branches. Now I can plug the tree and select what levels I want to choose. So Now, as you can see, all my walls, they're available within the specific level. And the floor height for every floor also represented in the similar structure. So we have a one floor height per each level. So now I can extrude my walls and see the geometry in Rhino. Let's delete this one. Let's use extrusion component. And let's use our walls. Yeah. And let's use the floor height as z vector extrusion. So it's like this, and height like this. And as you can see, I have right now the correct surface of all my walls within the model, like here. And obviously, this model in a Grasshopper automatically responds to all the changes done in Schema. So for instance, if I just go back here, I want to add more floors like this. And let's say I want to apply the same layout, but another variant for this block. And I want to do the same for other floors, like variant 2, variant 2, variant 2. And let's say I just need to remove some units here and shorten the circulation path. Now I have updated building shape. I can save it, go back to Rhino, and just recompute this model. And as you can see, I have updated geometry. This model can be used within multiple workflows. One of these is a parametric facade definition. So firstly, let's undo all my changes that I did for this exercise. And I've created the definition which works with this, which create this facade. So now I'm going to really quickly go through all the case steps for this definition. Firstly, I visualize the same analytical model in the Grasshopper for easy preview of its key elements. I just group it. I just select all the walls by their types and color them accordingly. So I now can identify where all my demising exterior and interior walls. Next important thing here is we have to get rid of all the authentication components in order to make it compatible with the ShapeDiver. This is important because we will have we don't need to authenticate on a ShapeDiver side because we will get the analytical model by directly connecting Schema and ShapeDiver. And we will get the analytical model as a text using import text ShapeDiver component. So I just simply remove all the steps and plug the text component and name it properly. But in order to be able to locally test this model, we can go back to our previous component and let's recompute it just to have the updated model. Yeah. And we can save this file locally, this JSON file locally on our computer. We can just press save text, save text. We can plug the JSON model as a content, and we need to specify the path. Let's see here, file path, and I just choose the this test JSON file as a mock file. Here we go. Now we saved our analytical model locally, and now if I go back to my script, I can use the same path to the same file And now I can test it locally and see how the logic will work when I upload it into ShapeDiver. Another important step is specifying which elements from the analytical model script should use. We can do it by going back to Schema, go back to the Beam tab, and we can just select a set of walls. In my case, I need to select the walls by pairs, and I can select walls on the opposite sides just to validate the grouping logic. So I can see that I have a 16 walls selected. I can download this selection as a JSON file, and if I go and check, I can see that this is a really simple JSON file which has walls and slabs and list of the IDs that user selected within the analytical model. And now back in Grasshopper, I can select the same file that I downloaded. Let's go to download, select these walls. And I can see that now my script will work with the walls that I selected here. So let's really quickly go through the key steps for the script. Let's switch off the preview, and firstly, we filter all the walls we want to work with. Next, we will define all the demising walls perpendicular to the user selected walls in order to identify where the abstraction for my glazing panels should go. So this way I can be sure that the glazing panels do not intersect with the demising walls. After that, I describe the panels and how they should be parameterized. So this is the definition of minimum and maximum ranges for solid and glazing panels, for glazing elements within my panels. And this algorithm provides me the really high-level information about what are the panels I can use and where is the solid and glazing elements within my panels. So finally, I have a tree which represent where I need to place solid parts and where I need to place glazing parts within every panel. And based on this high-level data, I can create two-story window panels. I can create a bottom panels and the top panels. And this is a sufficient information for me to build a full geometry for my facade, as you can see here. And here I can assign an important metadata for this geometry, like to which layer this geometry should belong to, as well as materials. And I can use here the ShapeDiver export components to be able to export the geometry back to Schema and for the preview. And also I can use another ShapeDiver export components which allow me to send this data directly to Rhino. So I can use it after all, I can use it for export back to Revit with Rhino.Inside. This part is dictate the UI for my application. It essentially described where the parameters should go, how they're named, all the aspects for my UI. And it's not only describe the parameters, but also I can tell here how a user will interact with my application. For instance, I can tell that window panels can be selectable, and on the right top corner of every glazing panel, I can show the pop-up menu which will redirect me to another Grasshopper definition which generate balconies. And I will show you how it works in a matter of seconds. So this part is done. Let's move to the next chapter. Now we are going to upload our definition to ShapeDiver and convert it to the web-based application. Let's open ShapeDiver and upload our definition. We can simply select the definition and grab it. Upload. Now we're going through the validation process on the ShapeDiver side, and after successful uploading, we will be able to save it as application. Here we go. Let's open the model. Now we can see the preview of all the parameters that we created in a Grasshopper script. And we need to firstly make this link shareable. I can also move it to my organization tenant here. And under developers tab, we need to allow direct embedding for my application, so it knows to which domain it can speak. I can save it and run the application. Everything is good. I can see the interface that I defined in a Grasshopper. And now I need to connect Schema and ShapeDiver together. Firstly, we need to go to Schema, and within the beam preview mode, we need to run a ShapeDiver application. I can click on it, and it will show you the menu on the top left corner, right to the ShapeDiver plugin button. I can see the gray circle. It indicates that our application are not connected yet. I can click to the ShapeDiver button and log in on the ShapeDiver side. And since I already logged in on the ShapeDiver, here I need to only confirm that I want to allow this client on the ShapeDiver side. Here we go. We now can see that this circle indicates green, meaning that our application are ready to be connected. Cool. Also, I can save the link to my ShapeDiver application straight here. I can go to my app, I can copy this URL, go back to Schema and simply press Add New button. I can call it like a panelized facade. Pass the URL, provide some descriptions as well as thumbnail, press Create, and now me and all my teammates will always have access to the relevant ShapeDiver application. And by clicking on it, it just redirect to a proper link. So here I can see the available schema client, and I just need to choose it. Straight after that, I can see that both required inputs became available on ShapeDiver side. And firstly, I want to fetch the analytical model. Perfect. I can see the preview of this model on the ShapeDiver side. And secondly, I need to select the walls in Schema and grab them on the ShapeDiver side. Let's select a few pairs of walls. Let's say this one. Like this. We can now go back to ShapeDiver and grab these walls. As we have all the inputs, scripts are automatically running, and we can see the result on the ShapeDiver side. We also can go back to Schema and select another walls and see the updated result on the ShapeDiver side, like here. Go back to ShapeDiver, upload selected walls, and see the result. So I can see all my panels, and I also can see and validate that all glazings, they are not intersected with the demising walls according to my logic. So here I can be sure that I have a relevant facade solution, not just something more or less similar like facade. Because we all know that architects never satisfied with something that looks like result. They need exact result. So here I can play with my parameters. For instance, I can increase the maximum range for the solid part of one of my panel, like here, and I can see that now I have the updated result. Also, I can play with other parameters like increasing glazing part, like here. Let's say I want to increase the glazing part for panel B, and I need to increase the minimum and maximum for other panels. So basically, this is settings which allow you to customize your facade. I also can choose the different materials for my panels and play with other parameters. Like here, yeah, I guess the white one works better. And also, I can push all this information back to schema. I can go to the export tab, go find my components, which I identify as the export geometry back to schema, essentially this one. I can go back to ShapeDiver and I push the output back to schema. Yeah, I can see that output is successful, and if I go back to schema, I can see all my preview of all my geometry. And also, with the latest ShapeDiver features, we can create a pretty complex solution by combining different Grasshopper definition and one application. Just really quickly show you how it works. For instance, in my application, I describe that glazing panels should be selectable. And if I click on it, we can run another Grasshopper definition which generate balconies. I also can specify the parameters for these balconies like depth or type of railings. For instance, I can change the solid railing to the glass one. And if I'm not satisfied with the result, I can remove it from my project. Here we go. So this is the quick overview of what we can build by combining schema analytical model and ShapeDiver web applications. And now that you've seen how it works, we can continue with the next steps. We are right now at the latest step of pushing everything back to Revit. Let's check the projects that we were exporting from Revit. Here we go. We can see that everything was successful. We don't have exterior walls as we switch them off. And we have all our units as model groups in a proper position. And if we go to the floor plan view, we also can see that we have only one set of demising walls without any duplicates, so the geometry is correct. So let's go back to the 3D view, and I will use this file as a reference for my facade. So I just want to close this file because this is the most common case while working with the facade to create it in another Revit file. So I just open the empty file and use this file as an external link. So I can just find it. Yeah, everything is perfect. I can close the schema application because I don't need it at this stage. And now I can run Rhino.Inside Revit and push the geometry from ShapeDiver. Let's firstly maximize the view. And the critical part, now we need to connect Rhino with ShapeDiver. So here I can just type the ShapeDiver. It proposed to do the similar actions that we did within Schema application, just to authorize ShapeDiver Rhino client. We can click yes, go back to Revit, and we can see that we successfully registered this client on the ShapeDiver side. So now I can run Grasshopper and go back to ShapeDiver. I can refresh my available clients, and I can see that I have a Rhino 8 as a client. I can choose this one, go to the Export tab, and under Output Revit tab, I can see that I can bake to the Rhino all my panels and curtain walls, the same way as I described here. So I described that I want to retrieve panels as a set of curves, and they should lay in the all panels layer. And for the rest of the geometry, I also specified the correct layer naming. Yeah. And this is the export component, which allows me to push this data back to Rhino from ShapeDiver. So now I can grab the panels first, go back to Revit. I can see all my panels, and I can check that they are in the correct layers. So yeah, as you can see, they lay in the all panels layer. I can close this one. I can go back to ShapeDiver, and I can do the same for the curtain walls. Curtain walls will be exported as just meshes. Go back to Revit and switch to the shaded view. So now I can see that I have a curves, I have a geometry, and all this data I will use for exporting back to Revit with via Rhino.Inside. Now let's open the components that I prepared. It's really simple. It basically query all the data within a particular layer, and for walls, it query the particular wall type within my Revit project and create a wall by extrusion. And for the rest of the geometry, I just push it as a generic objects. And now if I collapse the Rhino menu, I can see that my all my geometry were successfully transferred to Revit. So I can see that all my walls were exported panels by panels, and I can see that they were converted as a Revit system family walls, and the panels was exported as a generic models with a proper material assigned to this geometry. Finally, we have a well-coordinated building and facade model in Revit, which was generated based on the single source of truth, which is Schema Analytical model. That's it for today, and stay tuned for more.